Hello, ladies and gentlemen. My name is Abdurrahman Ali, and inshallah, today I'm going to solve question number 5 for mechanic of materials. The question says a rod consisting of two cylindrical portions, AB and BC, is restrained at both ends. Portion AB is made of steel, and it has the ES equal 200 gigapascal and AS equal to 11.7 times 10 to the power minus 6 degrees C, and portion BC is made of brass. E is equal to 105 gigapascal and AB is equal to 20.9 times 10 to the power minus 6 degrees C. Knowing that the rod is initially unstressed, determine the compressive force induced in ABC when there is a temperature rise of 50. So what exactly he wants? He wants the pressure which is applied here. Okay, or the force, which we call it total force. Force total is unknown. So first of all, how can we solve this issue? Because it's a cylindrical, so it's better to find the area first. We have to find the area for the brass and for the second material is steel. Okay, so let's say area of steel is equal to, we know the equation is pi d square. We have the diameter, we know it's 300. The diameter is 300. So it's gonna be 30 because it's in meter to the power 4. So I'm gonna get 706.5 millimeter square. And for area of brass, also the same, pi. We know it's 250. We know the diameter is 50, so we're gonna get 1962.5 millimeter square. So we found the area. So now let's see the question. Here we are dealing with thermal, so there is some heat is applied on the system. So how can we find our new equation? It's gonna be like this: total equal to thermal. Let's say it's thermal, the length after thermal for AB portion plus the thermal for BC portion. So now let's deal with this one. Is for thermal for AB is equal to the AS times delta T times L. We know AS, it's already given, which is 11.7 times 10 to the power minus 6. And we know delta T is 50. Times, we know the length is 250 times 10 to the power minus 3, because it's in millimeter, we need to convert it to meter. So we're gonna get 1.4 6 3 times 10 to the power minus 4 meter. And now we need to find delta thermal for BC. We know AS delta T times L. We know AS or we know AS is 2.09 times 10 to the power minus 6. We know delta T is 50. We know the length for that one is 300 times 10 to the power minus 3. So we know the delta is 3.135 times 10 to the power minus 4 meter. So now we have to add the delta length for AB portion and BC portion after heating. So we know it's equal. We take this number and this number, take this number and this number, we add them together to find the delta total. So we're gonna end up with 4.597 times 10 to the power minus 4 meter. So after we found the total, we have to plug it in our equation, or the old equation, which is, we know, equal to FAB times length of AB times the area of AB times EAB equal to the force of BC times the length of BC and the area of BC times E of BC. Equal to, we know here F of AB, we don't know it, and we know the length of this one, we found it after heating, which is 0.25, or before, actually before heating, FBC times 0.3, and we know the area is already, we found it out, times 6 times 10 to the power minus 6 times 200 times 10 to the power 9, because it's in gigapascal, and the area for BC portion is 1962, we already defined it, times 10 to the power minus 6 times 100 to the power minus, or sorry, 9. So after a little bit calculation, we know that delta total, delta total equal to 3.22 times 10 to the power minus 9 P, or F total. Then we plug this equation in our first equation, which is the total, plus the total equals 0. So we know is 4.59 times 10 to the power minus 4 plus 3.22 times 10 to the power minus 9 p. We know p is equal to, this one is equal to 0. So we know p is equal, after we divide this number with this number, so we're gonna get 14367.9 Newton. That's our final force. We call it F. So this is our F total. Thank you guys for watching. Hope to see you next time, inshallah.